This video will discuss a graphical solution to Electrocomp Corporation's problem. A problem formulation is shown. They need to determine the product mix of air conditioners and large fans that will maximize profit given their current resources. Decision variables are x1 is the number of air conditioners produced, and x2 is the number of large fans produced. The profit function is their objective function. $25 times each x1 plus $15 times each x2. The constraints are on wiring and drilling time available. These are each resource constraints. For a graphical solution, the first step is to graph lines for the equality parts of the constraint. To do this, we simply need 2 points on each of these lines. If we consider the first constraint, (3x1 plus 2x2) equals 240, the equality part, what we can do to find two points on this line is substitute 0 for x1, solve for x2, and then substitute 0 for x2 and solve for x1. Suppose we decide not to produce any units of the x1. So we substitute 0 for x1. This reduces the equation to 2 times x2 equals 240. If we solve for x2 by dividing by 2 on each side, we get x2 equals 120. So the first point on this constraint is x1 equals 0 and x2 equals 120. Consider the constraint again. What if we decide not to produce any large fans? In other words, we substitute 0 for x2. The equation reduces to 3 times x1 equals 240. If we divide by both sides by 3 to solve for x1, we get x1 equals 80. These are 2 points on the wiring time constraint line. Let's consider the second constraint. If we substitute 0 for x1, the equation will simply reduce to x2 equals 140. So 0 and 140 is 1 point on the drilling time constraint line. If we substitute 0 for x2, we need to solve for x1 by dividing both sides by 2. So the second point on the drilling constraint line is 70 and 0. Now we're ready to graph these two lines. We have x1 on the horizontal axis and x2 on the vertical axis. For the wiring time line, the first point is x1 equals 0 and x2 equals 120. We draw a point representing this constraint. This is the wiring constraint. For the second line, we have points at x1 equals 0 and x2 equals 140. and x1 equals 70 and x2 equals 0. We draw a line representing the second constraint. This constraint will be the drilling constraint. Both of these constraints are less than or equal to constraints. The region that holds the values, the combinations of x1 and x2 that satisfy both constraints lies below both of the constraints. It's called the feasible region. We need to choose a solution to our problem that lies in this feasible region. Because this is a profit maximization problem, we'd like to produce as many units of each product as possible, but the resources constrict us. So we want to move as far away from the origin as possible. We want to either be at one of these corner points or on one of the far lines of the feasible region. It turns out that any solution at a corner point will be just as good as a possible solution on one of these lines. So what we need to do is investigate the corner points. The first corner point is where x1 equals 0 and x2 equals 120. The profit at this corner point is 0 times 25 plus 120 times 15, or 1800. We simply substituted in the number of units of x1 and x2 into the profit function defined earlier. The second corner point of the feasible region is where x1 is 70 and x2 equals 0. The profit at this corner point is 70 times 25 plus 0 times 15, or 1750. The third corner point lies at the intersection of the two constraints. We need to solve simultaneously these two equations to find the point where they meet. Here's how we can go about doing this. We write down the first constraint. We solve for one of the variables in this constraint. Let's solve for x1. By moving the term for x2 to the right side. Then we would divide both sides by 3. Because there are two terms on the right side, we would divide each of them separately by x3. So we have 80 minus 2/3 times x2. Now we write down the equation for the second constraint. We substitute in the expression for x1 above. If we expand this, we have 160 minus 4/3 times x2 plus x2 equals 140. This simplifies to 160 minus 1/3 times x2 equals 140. We need to subtract 160 from both sides of the equation. That leaves 1/3 x2 equals negative 20. Now to solve for x2, we simply need to multiply both sides of this equation negative 3. This gives x2 equals 60. We substitute x2 equals 60 back into the expression for x1. 2/3 of 60 is 40. So we get x1 equals 40 and x2 equals 60. This is the third corner point. So the profit at that point is 40 times 25 plus 60 times 15, or 1900. Now we choose which of these corner points gives the highest profit. And as we can see, it's corner point number 3. So our solution: produce x1 equals 40, or 40 air conditioners, and x2 equals 60, or 60 large fans.